The cattle car lurched to a stop somewhere in eastern France, and Dieter Hoffmann pressed his face against the gap in the wooden slats, expecting to see the gallows. It was November 19th, 1944, and for the past 6 days, the 32-year-old mechanical engineer had been certain that each rumble of the train's wheels brought him closer to execution. He had heard the stories whispered among Wehrmacht soldiers during the collapse at Aachen. American forces didn't take prisoners who understood the Reich's industrial secrets. They couldn't afford to. Through the narrow opening, Hoffmann saw not execution grounds, but something far more disturbing. Row upon row of American trucks, parked in perfect geometric precision, stretching toward the horizon. He counted 60 vehicles before losing track, and this was merely what he could see through a 4-inch gap. Each truck appeared identical, factory fresh, their olive-drab paint reflecting the grey November light. In 3 years working at the Krupp Steelworks in Essen, Hoffmann had never seen such abundance of anything. The door slid open with a metallic shriek. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Before the war consumed everything, Dieter Hoffmann represented the pinnacle of German technical education. He graduated from the Technical University of Berlin in 1938 with highest honors in mechanical engineering, his thesis focusing on metallurgical improvements in steel production. The Third Reich recruited him immediately, not as a soldier, but as something the regime considered far more valuable, an industrial problem solver. By 1940, at age 28, he was managing quality control for armor plate production at the Krupp facility, one of the Reich's most critical manufacturing centers. The Germany Hoffmann served believed absolutely in its technical superiority. This wasn't mere propaganda, it was doctrine, reinforced by genuine achievements. German optical instruments remained the world's finest. The Reich's chemical industry had pioneered synthetic fuel production, allowing Germany to wage war despite having almost no natural petroleum reserves. German engineers had developed the first operational jet aircraft, the Messerschmitt 262, which entered limited service in the summer of 1944. These weren't lies. They were facts, and they formed the foundation of a worldview that made sense of everything else. At Krupp, Hoffmann witnessed daily miracles of improvisation. When tungsten supplies from Portugal became unreliable in 1943, his team developed alternative hardening processes that maintained armor quality with less exotic materials. When Allied bombing destroyed the main rolling mill in March 1943, they had substitute production running within 41 days. Germans, Hoffmann had been taught since childhood, possessed a unique capacity for precision, for order, for technical excellence. The Americans, by contrast, were cowboys wasteful, unsophisticated, reliant on brute quantity rather than elegant engineering. The numbers seemed to support this narrative. Hoffmann knew that a single German Panther tank required approximately 18,000 man-hours to produce. American Shermans, by comparison, needed only 10,000 hours clear evidence, he believed, of inferior construction and design. The Panther's frontal armor measured 3.5 inches thick, sloped at 55 degrees. The Sherman's frontal plate was barely 2 inches, nearly vertical. In direct combat, the Panther could destroy a Sherman at ranges exceeding a mile, while the American tank needed to close within 500 yards to penetrate German armor. These facts were irrefutable. What Hoffmann didn't know, what no one at Krupp discussed, was that American factories produced 5 Shermans in the time Germany manufactured 1 Panther. He didn't know that Ford's Willow Run plant in Michigan was building 1 B-24 Liberator bomber every 63 minutes by the spring of 1944. He didn't know that American steel production in 1943 reached 80 million tons, while Germany's entire output, including occupied territories, barely exceeded 30 million tons. These statistics existed, but they existed outside the informational universe that German engineers inhabited. The collapse, when it came, felt geological, as if the earth itself had shifted beneath the Reich's industrial foundations. The Allied landings in Normandy on June 6, 1944, were catastrophic, but Krupp's production actually increased that summer. Then came the systematic destruction of Germany's transportation infrastructure. American 8th Air Force bombers began targeting not factories but the railway marshalling yards, the canal locks, the bridges, the circulatory system that moved raw materials to plants and finished products to the front. By September 1944, Hoffmann was receiving less than 40% of required steel stock. Finished tank chassis sat immobile in the Krupp yards, waiting for engines that never arrived because the plant producing them had no coal. Spare parts became precious as gemstones. A Tiger tank transmission, a component that required replacement every 800 miles under optimal conditions, became almost impossible to source. Hoffmann watched crews cannibalize 3 damaged tanks to create one functional vehicle. On October 2, 1944, American First Army units entered Aachen, the first German city to fall. Hoffmann received evacuation orders on October 14th. He was to move critical technical documents and himself to facilities further east, deeper into the shrinking Reich. The journey lasted 36 hours in the back of a Pleiss Wehrmacht truck that broke down 4 times. Each repair revealed the same problem: ersatz parts that couldn't withstand normal stress, rubber hoses made from synthetic compounds that cracked in cold weather, bolts cast from recycled scrap metal that sheared under load. The improvisation that Hoffmann had once viewed as engineering ingenuity now revealed itself as desperation. He never reached the reassignment destination. American artillery destroyed the bridge at Düren on October 16th, and Hoffmann's convoy found itself trapped in a pocket with elements of the 9th Panzer Division. For 3 weeks, they retreated through villages whose names he barely registered. The panzers ran out of fuel outside Eschweiler. The crews set demolition charges and walked away from machines that had cost the Reich's industrial capacity dearly. Hoffmann surrendered on November 13, 1944, walking into American lines with 11 other engineers and technicians from Krupp. They had no weapons. They carried identification papers and technical certifications, documents that identified them as skilled workers essential to the Reich's war effort. Hoffmann believed these papers were death warrants. The Soviets, according to Wehrmacht intelligence briefings, shot technical prisoners to prevent them from aiding the Reich's industrial recovery. Surely the Americans would do the same. The American lieutenant who processed Hoffmann's surrender was 23 years old, younger than most of the German engineering apprentices. He barely glanced at the identification papers. Through a translator, he asked 3 questions: name, hometown, current health status. Then he handed Hoffmann a cardboard tag with a number printed on it and directed him toward a line of waiting trucks. The trucks themselves were the first anomaly. They were GMC 6x6s, 2.5-ton cargo carriers, and they were everywhere. Hoffmann counted 43 vehicles in the immediate assembly area, with more arriving in a steady stream along the road. Each truck was identical, produced to tolerances that allowed completely interchangeable parts. The tires showed minimal wear. The engines ran smoothly, no misfires or irregular combustion sounds. These weren't vehicles being nursed along through mechanical improvisation. These were tools being used and replaced as needed. The POW camp at Foucaultville, where Hoffmann's truck arrived after 6 hours, contained approximately 4,000 German prisoners in an area that measured perhaps 60 acres. American engineers had constructed it in less than 2 weeks. Hoffmann knew this timeline was accurate because he spoke with Wehrmacht soldiers who had been captured during the Normandy breakout in early August and transferred here when the camp opened. The construction speed seemed impossible until he observed the methods. American engineers didn't build structures in the European sense. They assembled them. Prefabricated sections arrived on trucks, already cut and drilled. Tents weren't erected. They were unrolled from factory packages with standardized pole assemblies that slotted together without tools. The mess hall that fed 4,000 prisoners 3 times daily consisted of 18 structures that could be disassembled and relocated in less than a day. But it was the food that first cracked Hoffmann's understanding of material reality. The evening meal on November 19th consisted of tinned meat, white bread, dehydrated potato powder, reconstituted with water and margarine, and coffee made from actual coffee beans. The portion size was larger than anything Hoffman had eaten since 1942. The bread was soft, made with refined wheat flour that contained no sawdust, no extenders, no adulterants that German bakers had been forced to use since shortages began. The American sergeant supervising the meal distribution was eating the identical food from identical tin plates. This detail struck Hoffman as profoundly significant. In the Wehrmacht, officers' rations were marginally better than enlisted men's, and both were considerably superior to civilian allotments. The Americans seemed to operate on a different principle. They had manufactured enough of everything that hierarchical distribution became unnecessary. Over the following days, Hoffman began conducting a personal inventory of American material culture with the systematic approach of an engineer analyzing a manufacturing process. The guards wore uniforms of heavy cotton twill, well constructed with reinforced seams and functional pocket designs. Each guard had 2 complete uniforms in rotation, plus a winter coat of wool and cotton that showed no signs of synthetic substitutes. Their boots were leather, properly tanned and stitched, with rubber soles that weren't crumbling from poor vulcanization. The camp's latrines used actual porcelain fixtures, not the makeshift arrangements common in Wehrmacht field positions. The water supply came through buried pipes, not tanker trucks. Electric lighting illuminated the compound at night, powered by gasoline generators that ran continuously without apparent concern for fuel consumption. Hoffman estimated the camp used more gasoline for lighting in one night than an entire German panzer company received for a week's operations. The Americans discarded things that Hoffman would have salvaged and repaired. He watched guards throw away boots with worn heels, shirts with torn elbows, canteens with small dents. In the trash collection area itself, a concept that implied surplus, Hoffman saw perfectly functional cigarette lighters, mess kits with minor damage, even wristwatches with broken straps. In Germany, any of these items would have been repaired and redistributed. Here, replacement was cheaper than repair. On November 27th, American intelligence officers began systematically interviewing prisoners with technical backgrounds. Hoffman's turn came on December 1st, 1944. The interview lasted 4 hours and covered his entire career at Krupp. The American captain conducting the session, a man who introduced himself as having studied metallurgy at Carnegie Institute of Technology before the war, asked detailed questions about production processes, quality control measures, supply chain problems, and output figures. Hoffman answered truthfully. He had no reason not to. The war was clearly lost, and these Americans seemed far more interested in understanding German industrial methods than in punishment. What shocked him was the captain's casual revelation of American production statistics, delivered not as secrets but as simple facts. "Your Krupp facility produced how many finished tanks in October?" the captain asked. "Approximately 140 units," Hoffman replied, though many were awaiting final components. The captain made a note. "We built about 2,000 medium tanks that month, plus another 800 tank destroyers and self-propelled guns." He said this with the tone one might use to discuss the weather. Hoffman assumed he had misunderstood the translation. 2,000 per month from your largest factory. No, that's total national production. Chrysler's Detroit Arsenal tank plant makes about 500 Shermans monthly by itself. The captain paused. "You worked in quality control, yes? What sort of rejection rate did Krupp maintain for armor plates?" The conversation continued, but Hoffman's attention fragmented. 500 tanks from a single factory. He tried to reconcile this number with everything he understood about industrial capacity. The Reich's entire tank production for 1944 would barely exceed 18,000 units, and this required every major German manufacturer operating at maximum capacity with increasingly severe raw material constraints. If American numbers were accurate, and Hoffman was beginning to suspect they were, then the United States was outproducing Germany by a factor of 4 or 5 in armored vehicles alone. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The full revelation came in January 1945, when American authorities began organizing work details from prisoners with industrial experience. Hoffman was assigned to a maintenance crew servicing vehicles at a forward supply depot near Saint-Lô. The work itself was simple, changing oil, replacing filters, performing basic mechanical checks on trucks returning from forward areas. But the scale of operations surrounding this routine maintenance shattered what remained of Hoffman's pre-war worldview. The depot occupied approximately 12 square miles of Norman farmland. American engineers had covered this area with gravel, installed lighting, and organized it into functional zones: vehicle maintenance, spare parts, warehousing, fuel storage, ammunition dumps, and general supply distribution. Hoffman's section represented perhaps 2% of the facility's total area. On his first day, January 8, 1945, Hoffman counted trucks. This was a habit, the engineer's compulsion to quantify. He reached 3,000 before stopping, and he had surveyed perhaps a quarter of the depot's vehicle park. The trucks were GMCs, mostly, along with Dodge 3/4 tons and Studebaker 6s supplied to the Soviets under Lend-Lease, but temporarily rerouted here. All were maintained to identical standards, serviced on schedules that prioritized preventive maintenance over emergency repair. The spare parts warehouse occupied 6 buildings, each approximately 200 feet long. Hoffman gained access to one building while retrieving engine filters. The interior consisted of floor-to-ceiling shelving, organized with the same systematic precision he had once believed uniquely German. But the quantity of components defied his reference points. The single building stored more replacement transmissions than Germany had likely produced in total for all vehicle types in 1944. The carburetor section, just carburetors, contained thousands of units, each in factory packaging, each absolutely identical and interchangeable. An American mechanic, noticing Hoffman's expression, offered an explanation through casual conversation. This depot supplies 1st and 9th Armies, covers about 40,000 vehicles in active service, plus reserves. We rotate complete trucks out every 60,000 miles for rebuilding, so there's constant throughput. Hoffman did the arithmetic. 40,000 vehicles in this sector alone. The Third Army, under Patton, operated independently with its own supply network. The British and Canadian forces maintained separate logistics. Even conservative estimates suggested the Western Allies were operating 250,000 trucks in the European theatre, probably more. Germany's entire military vehicle inventory, trucks, half-tracks, armoured cars, motorcycles, everything with an engine numbered perhaps 500,000 units at the war's peak in 1942, and this included captured equipment from occupied territories. The Americans had apparently built that many vehicles specifically for European operations in approximately 18 months, while simultaneously conducting a massive Pacific campaign. The steel revelation came not as a single moment, but as an accumulation of observations that Hoffman could no longer rationalize away. It began with something as mundane as fencing. The Saint-Lô depot's perimeter consisted of chain-link fencing, approximately 8 feet tall, supported by steel posts set in concrete at 12-foot intervals. The fencing enclosed the entire 12-square-mile facility, roughly 60 miles of linear barrier. Hoffman had worked with steel allocation at Krupp long enough to calculate approximate tonnage. The fencing alone represented perhaps 1,500 tons of drawn steel wire and structural posts, used for nothing more critical than marking boundaries and providing minimal security. 1,500 tons. In the summer of 1944, Hoffman had fought for 3 weeks to secure an emergency allocation of 800 tons of specialty steel for tank transmission housings. The request had travelled through 5 levels of bureaucracy and required the personal intervention of an armaments ministry official. The Americans had used nearly twice that amount to build a fence around a single supply depot. But fencing was trivial compared to what Hoffman observed in the maintenance facilities. Each of the depot's 6 vehicle service bays was constructed from structural steel, I-beams, angle iron, corrugated roofing panels, all erected with the temporary permanence of military construction that expected to be disassembled and relocated. An American engineering lieutenant, perhaps sensing Hoffman's constant calculations, explained that the depot had been built in October 1944 and would likely be abandoned by March or April 1945 as the front moved eastward. Abandoned? Hoffman asked through the camp translator who accompanied work details. Will the steel structures be dismantled and shipped forward? The lieutenant shrugged. Probably not. Cheaper to build new ones with fresh materials than to spend the labor hours on disassembly and transport. Some of it might get salvaged if rear echelon units want it, but mostly we'll just leave it for the French. The statement was delivered casually, without any apparent awareness of its implications. The Americans were planning to abandon several thousand tons of structural steel because the logistical cost of recovery exceeded the material's value. This was not improvisation. This abundance was so extreme that waste became economically rational. Hoffman began noticing steel everywhere, in applications that German engineers would have reserved for less critical materials. Ammunition crates were steel, not wood. Water barrels were steel, not wood or canvas. Even mundane items like garbage cans, latrine dividers, and tool storage boxes were stamped from sheet steel with the casual abundance of a production system that had solved scarcity. The vehicles themselves represented steel consumption on a scale that made Hoffman's earlier calculations seem naive. A single GMC 6x6 truck weighed approximately 11,000 pounds empty. Assuming 70% of that weight was steel and iron components, a conservative estimate each truck represented perhaps 3.5 tons of ferrous metal. The 40,000 trucks supplying 1st and 9th Armies therefore embodied approximately 140,000 tons of steel used solely for transportation infrastructure, not including the tanks, tank destroyers, artillery pieces, or the thousands of specialized vehicles like bulldozers, cranes, and wreckers. 140,000 tons. Germany's total steel production in January 1945 would be approximately 1.5 million tons, but much of this was low-grade material recycled from scrap or produced in facilities operating with severely degraded equipment. Germany was producing less steel in a month than the Americans had committed to trucks in a single theater of operations. On January 23, 1945, an American supply officer gave a routine briefing to work detail supervisors about expected material flows for the coming spring offensive. Hoffman, assigned to translate German prisoner responses to questions about vehicle maintenance experience, sat in on the briefing. The officer distributed mimeographed sheets showing projected ammunition expenditures, fuel consumption, rates, and replacement vehicle schedules. The ammunition numbers were staggering. The projected consumption for the 1st Army alone during the first week of the spring offensive was listed as 420,000 artillery shells of all calibers. Each shell required a steel casing, varying from 20 pounds for 75mm rounds to nearly 200 pounds for 8-inch howitzer shells. Using median weights, the steel consumption for artillery ammunition in 1 week, for one army, exceeded 30,000 tons. Hoffman had seen similar calculations at Krupp. The Wehrmacht's ammunition crisis in late 1944 had stemmed not from explosive shortages, but from the inability to produce enough steel casings. German artillery units in the West were rationed to approximately 15 shells per gun per day by December 1944, not because the Reich lacked explosives or propellant, but because shell casing production had collapsed under the combined pressure of raw material shortages and systematic Allied bombing of steel mills. The Americans were planning to fire more shells in 1 week than the entire Wehrmacht could produce in a month. This wasn't battlefield exaggeration. These were logistics projections, prepared by supply officers who would be relieved of duty if their estimates proved inaccurate. After the briefing, Hoffman remained in the office area, ostensibly to complete vehicle maintenance reports. An American sergeant, perhaps 3 or 4 years younger than Hoffman, was filing supply requisitions. They exchanged a few words, the sergeant spoke, some German learned from immigrant grandparents. The conversation was inconsequential until the sergeant mentioned, almost as small talk, that his brother worked at U.S. Steel's Gary Works plant in Indiana. Big facility? Hoffman asked, maintaining a tone of polite interest. Pretty big, the sergeant replied. They're running about 1 million tons a month now, my brother says. Maybe more. Shifts are 12 hours, 6 days a week. Good money, but hard work. 1 million tons monthly. From a single industrial complex. Hoffman knew Gary Works was large. Even German technical journals had covered American steel production capacity before the war, but he had assumed those production levels were theoretical maximums, achieved briefly under optimal conditions. The sergeant was describing sustained wartime output as routine. That evening, Hoffman attempted to reconstruct what he knew about American steel production from pre-war technical literature and the fragments of information he had accumulated over 3 months of captivity. U.S. Steel operated multiple facilities beyond Gary Works. So did Republic Steel, Bethlehem Steel, and at least a half-dozen smaller corporations. Even using conservative estimates, American steel production was likely exceeding 8 million tons monthly, perhaps 9 million. The number was almost meaningless. Hoffman couldn't contextualize 8 million tons because he had no reference point for industrial capacity at that scale. Germany's entire 1943 steel production had been approximately 30 million tons, an output achieved only by stripping occupied territories of their industrial equipment and working German facilities beyond sustainable capacity. The Americans were producing that much every 90 to 100 days. He tried to calculate backwards from observable evidence: the vehicles, the ammunition, the structural steel for temporary buildings, the fencing, the countless small applications of steel in tools and containers and equipment. If 1st and 9th Armies represented perhaps a quarter of American ground forces in Europe, and European operations consumed perhaps half of total American military production, then the observable steel consumption in this single depot extrapolated to something like 5 million tons of steel allocated to military vehicle production, alone, annually, just for the European theatre. 5 million tons, for trucks, not including ships, aircraft, tanks, artillery, ammunition, or the thousands of other applications that modern warfare demanded. 5 million tons of steel, used casually, wasted, openly, abandoned as economically inefficient to recover. Hoffman had expected execution. Instead, the Americans had given him a revelation that was, in its own way, more devastating than any bullet. Everything he had believed about German technical superiority, about the Reich's industrial capacity, about the fundamental capabilities of German organization versus American carelessness, all of it was wrong. Not mistaken, not slightly inaccurate. Completely, foundationally, catastrophically wrong. The wrongness extended beyond mere numbers. It revealed a conceptual failure that was almost philosophical. German engineers had optimized for precision. Every tank was a carefully crafted machine, designed to outperform enemy equivalents in direct combat. This seemed logical, even necessary. Why produce inferior equipment? But the Americans had optimized for volume, accepting reduced individual performance in exchange for overwhelming numerical superiority. A Sherman was inferior to a Panther in nearly every technical specification. But it didn't matter because American factories produced 5 Shermans for every Panther, and Sherman crews learned that 4 or 5 tanks working cooperatively could destroy any German armor they encountered. German submarines were technical marvels, capable of diving deeper and running quieter than any Allied equivalent. But American shipyards built merchant vessels faster than U-boats could sink them. The United States launched roughly 5,000 merchant ships during the war years, totaling approximately 50 million tons of shipping. German submarines sank perhaps 3,000 Allied vessels, approximately 14 million tons, a catastrophic loss by any historical standard, but ultimately meaningless because American production had solved the arithmetic of attrition. In February 1945, Hoffman was transferred to a larger POW facility at Camp Lucky Strike near Le Havre, a sprawling complex that held approximately 50,000 German prisoners awaiting repatriation or war crime screening. The camp's construction had required more engineering sophistication than its temporary nature suggested. Drainage systems prevented the camp from becoming a mud field during winter rains. Water distribution provided potable water to 50,000 men without disease outbreak. The mess facilities served 150,000 meals daily, using an industrial food preparation system that seemed more factory than kitchen. An American civil engineer, a captain from the Army Corps of Engineers, supervised the camp's ongoing maintenance. He had studied at MIT before the war and spoke enough German to hold technical conversations. Hoffman, by this point, had stopped pretending indifference to American industrial capacity. He asked directly, "How much steel did America produce in 1944? The captain considered this. "About 80 million tons, I think. Maybe 82 million. I'd have to check the exact figures." He paused. "Why do you ask?" "Professional curiosity," Hoffman said, which was truthful enough. 80 million tons, annually. The number was so large that Hoffman's mind initially rejected it as a translation error. But the captain had said it casually, as one might cite the population of a large city or the distance between Berlin and Munich. 80 million tons was not a theoretical maximum capacity. It was actual production, achieved while America simultaneously built thousands of aircraft, hundreds of ships, and maintained a civilian economy that was, by all accounts, experiencing unprecedented prosperity. The Germans had lost the war in September 1939, the moment they invaded Poland. They simply hadn't known it yet, because the machinery of their defeat required several years to reach full production capacity. Every tactical victory, every brilliant operational maneuver, every technological innovation, all of it was irrelevant against an opponent who could outproduce the Reich by factors of 3 or 4 or 5 in every critical material category. Hoffman thought about his colleagues at Krupp, the engineers and managers who had worked themselves to exhaustion trying to maintain production levels with shrinking resources. They had believed their work mattered, that precision and innovation could overcome material disadvantage. This belief was necessary. Without it, the psychological burden of their situation would have been unbearable. But it was also tragic, because they had been attempting to win a war that industrial mathematics had already decided. In late March 1945, news reached Camp Lucky Strike that the Krupp works in. Essen had been captured by American forces. The facility Hoffman had left 5 months earlier was now occupied territory, its machinery likely damaged or destroyed, its workforce scattered. He felt surprisingly little emotion about this. The Krupp works had been dying slowly since 1943, starved of raw materials and skilled workers. The American occupation simply formalized what had already occurred. What Hoffman felt instead was a kind of exhausted clarity. The war had been lost not through moral failure or tactical incompetence, though both existed, but through a fundamental misunderstanding of industrial reality. The Third Reich had built its strategy on assumptions about material capacity that were wrong by orders of magnitude. German intelligence had known American steel production was higher than Germany's, but the estimates had been wrong by factors of 2 or 3, and no one in authority had understood what those numbers meant when translated into actual military capability. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By April 1945, the war in Europe was clearly ending. Soviet forces were fighting in Berlin. American and British forces had crossed the Rhine and were advancing through central Germany against collapsing resistance. Hoffman listened to news reports with the detachment of someone observing events that had been predetermined years earlier. The outcome had never been in doubt. Only the timing remained uncertain. The psychological weight of this realization was, in some ways, heavier than the physical deprivation of captivity. Hoffman had been trained to believe in German technical excellence as an almost spiritual truth. The engineers at the Technical University of Berlin, the professors who had shaped his understanding of manufacturing and design, had taught their students that German precision represented a kind of industrial enlightenment. Other nations might produce larger quantities, but only Germany produced perfection. This belief system had made sense of the world. It explained why Germany could challenge opponents with greater populations and resource bases. Superior organization, superior technology, superior training. These qualitative advantages would overcome quantitative disadvantages. The belief was comforting because it was partially true. German engineering was excellent. German manufacturing processes were sophisticated. Individual German weapons systems often were superior to their Allied counterparts. But excellence, Hoffmann now understood, was not the same as adequacy. A Panther tank was an excellent machine, but excellence became irrelevant when American factories produced 15,000 Shermans in the time Germany manufactured 3,000 Panthers. A Tiger tank, with its 88mm gun, could destroy any Allied tank it encountered, but this capability meant nothing when the Tiger's mechanical complexity required 30,000 man-hours to produce and constant maintenance that frontline units couldn't provide. The Americans had designed their military equipment not for individual excellence but for what they called good enough, a concept that would have been insulting to Krupp but which proved strategically superior. A Sherman tank was good enough to destroy Wehrmacht infantry positions, good enough to provide mobile fire support, good enough to be repaired by minimally trained mechanics using interchangeable parts, and crucially, good enough to be produced in numbers that made tactical losses irrelevant. In May 1945, following Germany's surrender, American authorities began processing POWs for repatriation. The system was bureaucratic but efficient, organized with the same systematic approach that characterized American logistics. Hoffmann's case was complicated by his position at Krupp, which required additional screening to determine if he had been involved in war crimes. The use of slave labor was standard practice at major German industrial facilities, though Hoffmann's specific role in quality control placed him outside direct involvement. The investigation lasted 6 weeks. During this time, Hoffmann lived in a holding camp near Reims, where conditions were significantly better than active POW facilities. The Americans seemed less interested in punishment than in documentation, endless documentation of everything the Reich had done and how it had been organized. Engineers and technical personnel were particularly valuable sources because they could explain production processes, equipment capabilities, and supply chain systems. Hoffmann answered every question truthfully. There seemed little point in evasion. The war was over, the Reich was destroyed, and the information he possessed about steel production at Krupp would be discovered regardless of his cooperation. What surprised him was American interest in German methods, not as war crimes evidence, but as technical information worth studying. U.S. Army Major, formerly a production manager at Ford before his commission, spent 3 hours discussing Krupp's manufacturing techniques with genuine professional interest. The Major wanted to understand how German engineers maintained quality with degraded materials, how they organized production flows with disrupted supply chains, and how they motivated workers under increasingly desperate conditions. "You were producing good tanks with terrible steel by 44, the Major said. "That's impressive, in its way. Wrong strategy, obviously, but impressive execution." The comment crystallized something Hoffmann had been struggling to articulate. German engineers had been brilliant at solving the wrong problem. They had optimized for precision when they needed to optimize for volume. They had focused on individual weapon superiority when they needed to focus on logistical sustainability. They had designed manufacturing systems for quality control when they needed to design for rapid production and easy repair. These weren't moral failures. They were strategic failures rooted in a fundamental misunderstanding of modern industrial warfare. The Americans had understood something that German military doctrine had missed. Wars between industrial powers weren't won by superior tactics or better weapons. They were won by superior production capacity and more efficient resource allocation. Everything else was detailed. In July 1945, Hoffmann received clearance for repatriation. He would return to the British occupation zone in Western Germany, to a country that no longer existed in any meaningful sense. The Third Reich was gone. The industrial infrastructure that Hoffmann had served lay in ruins, bombed and stripped and divided among the victors. Krupp's factories would be dismantled, their machinery shipped, the Soviet Union, or scrapped. The Technical University of Berlin, where Hoffmann had studied, had been heavily damaged in the final battle for the city. Before departure, he received a final interview with an American intelligence officer, a perfunctory session to confirm biographical details and future residence. The officer mentioned, almost as an aside, that the United States was beginning a reconstruction program for Europe. Technical personnel would be needed. Engineers with manufacturing experience might find opportunities. Hoffman didn't respond immediately. The suggestion seemed surreal that the victors might employ him, might value the skills he had used in service of their enemy. But the officer seemed sincere, and Hoffman realized this too reflected American pragmatism. They had won the war through industrial capacity. Now they would win the peace through industrial reconstruction, and German technical knowledge might serve that purpose. He returned to Germany in August 1945. The country he found bore little resemblance to the nation he had left 9 months earlier. Cities were rubble. Infrastructure was destroyed. The population was hungry, displaced, traumatized by years of war and the revelation of atrocities committed in their name. Hoffman made his way to his parents' home outside Stuttgart, discovering that both had survived the war, but his younger brother had been killed during the defense of Budapest in December 1944. The personal loss was profound, but Hoffman found he had little emotional capacity left for grief. He had spent the past months confronting a different kind of loss, the loss of certainty, the collapse of a worldview that had structured his entire adult life. His brother's death was tragic, but it was also inevitable within the system that had produced it. Young men died in wars, especially wars that had already been lost when they began. In September 1945, Hoffman accepted a position with a German engineering firm contracted to assist British occupation authorities with infrastructure reconstruction. The work was unglamorous, repairing roads, rebuilding bridges, restoring basic utilities, but it was work, and work provided purpose when everything else seemed meaningless. He discovered he was good at this type of engineering, the practical application of technical knowledge to immediate human needs. Over the following years, Hoffman participated in Germany's reconstruction, watching as Allied assistance, particularly American economic aid through the Marshall Plan, rebuilt German industrial capacity. The irony wasn't lost on him. The same industrial power that had produced 80 million tons of steel annually to destroy Germany was now directing a fraction of that capacity toward its reconstruction. By 1950, West Germany's steel production had recovered to approximately 12 million tons annually, approaching pre-war levels. The difference was that this production now served civilian reconstruction rather than military expansion. The Krupp works, or what remained of them, were repurposed for peaceful manufacturing. The engineering skills that Hoffman and his colleagues had developed during the war now rebuilt what war had destroyed. Hoffman never spoke publicly about his wartime experiences or his time in American captivity. There seemed little point. Germany was engaged in a collective amnesia about the war years, focusing on reconstruction rather than reflection. But privately, in conversations with other engineers who had served the Reich, he would sometimes discuss what he called the steel revelation, the moment when he understood that Germany had never had any possibility of victory. Some of his colleagues rejected this conclusion. They argued that Germany could have won if certain decisions had been different, if resources had been allocated more efficiently, if particular battles had gone differently. Hoffman listened to these arguments with patient skepticism. They were comforting counterfactuals, but they ignored the fundamental arithmetic of industrial capacity. Germany produced 30 million tons of steel in 1943. America produced 80 million. No amount of tactical brilliance could overcome a material disadvantage of that magnitude. The Reich's defeat wasn't determined by specific battles or strategic errors. It was determined by industrial production capacity, and that capacity had been established years before the war began. In 1953, Hoffman was invited to deliver a lecture at the newly reopened Technical University of Berlin, now located in the western sectors of the divided city. The topic was post-war industrial recovery, but Hoffman used the opportunity to discuss something he considered more important: the relationship between engineering excellence and strategic realism. "We were taught," he told the students, that German engineering represented the highest standard of technical achievement. This was true, but we were not taught that excellence is not the same as sufficiency. We designed perfect machines when we needed adequate machines in large numbers. We optimized for individual superiority when we needed to optimize for collective capability. These were not failures of engineering, they were failures of strategic thinking. The lecture was not well received by some faculty members, who felt Hoffman was criticizing German technical traditions, but younger students, those who had been children during the war, seemed to understand his point. They were inheriting an engineering culture that needed to adapt to new realities, and Hoffman's message that technical excellence must serve strategic purpose resonated with their experience of rebuilding from ruins. Hoffman retired in 1972, at age 60. He had spent the post-war decades as a consulting engineer, working on industrial projects throughout West Germany and occasionally in other European countries. He had witnessed Germany's economic miracle, the transformation of a devastated nation into one of the world's most prosperous industrial economies. He had contributed to this transformation in modest ways, applying the skills he had learned at Krupp to peaceful purposes. He died in 1989, just months before the Berlin Wall fell and Germany began its reunification. His obituary in the local Stuttgart newspaper mentioned his contributions to post-war reconstruction, but said nothing about his wartime service. This was typical. A generation of German engineers had served the Reich, had applied their skills to military production, and then had spent the post-war decades rebuilding what their work had helped destroy. Few spoke about this transition. It was understood, accepted, and largely unexamined. But Hoffman had left behind personal papers, donated after his death to the Technical University's archives. Among these papers was a private memoir, written in the 1960s but never published. The memoir focused on his months in American captivity and the psychological impact of confronting American industrial capacity. "I expected death," Hoffman wrote in the memoir's opening pages. "Instead, they gave me 5 million tons of steel, not literally, of course, but as a revelation of what was possible when industrial capacity aligned with strategic purpose. The Americans had built a military machine so vast that individual tactical defeats meant nothing. They lost battles and continued advancing. They lost thousands of tanks and produced thousands more. They accepted casualties that would have crippled German formations and simply replaced their losses." The memoir continued. "We at Krupp believed we were engaged in a competition of technical excellence. We were wrong. We were engaged in a competition of industrial capacity, and we brought precision tools to a mass production contest. The Americans understood something we did not. Modern war is fundamentally an industrial problem, not a military one. Victory belongs to whoever can produce the most material with acceptable quality in the shortest time. Excellence is a luxury, irrelevant when the opponent can field adequate equipment in overwhelming numbers." These reflections, written decades after the events they described, reveal the psychological journey of a man who had confronted the collapse of his foundational assumptions. Hoffman had been trained to believe in German technical superiority as an almost metaphysical truth. His captivity had forced him to recognize that this belief, while comforting and partially justified, was strategically meaningless against an opponent whose industrial capacity operated at a scale beyond German comprehension. The 5 million tons of steel, a figure Hoffman used as shorthand for American vehicle production capacity allocated to European operations, represented not just material abundance, but a fundamental difference in strategic thinking. The Germans had asked, "How can we build the best possible tank?" The Americans had asked, "How can we build enough adequate tanks to guarantee victory?" The first question led to the Panther and the Tiger, magnificent machines that consumed resources and required specialized maintenance. The second question led to the Sherman, a mechanically reliable platform that could be produced in vast numbers and repaired by ordinary mechanics. Neither approach was wrong from a pure engineering standpoint, but in the context of total war between industrial powers, the American approach was strategically superior because it accepted the reality of industrial warfare. Victory belonged to whoever could sustain material output over years of attrition, not to whoever produced the most sophisticated individual weapons. Hoffmann's realization, brought through months of captivity and years of reflection, was that German engineering culture had optimized for the wrong variables. This wasn't a moral judgment. It was an observation about the relationship between industrial capacity and military strategy, one that had profound implications for understanding not just Germany's defeat, but the nature of modern warfare itself. The Americans hadn't defeated Germany through superior tactics, or better soldiers, or more brilliant generals, though they had all these things in adequate measure. They defeated Germany by outproducing the Reich by factors that made tactical considerations irrelevant. They built 80 million tons of steel when Germany built 30 million. They produced 50,000 aircraft when Germany produced 40,000. They constructed 5,000 ships when Germany couldn't replace the 700 U-boats lost in the Atlantic. These numbers, accumulated over years of war, created material superiority so overwhelming that German tactical excellence became meaningless. A Wehrmacht division, even if superbly trained and equipped, couldn't advance when it lacked fuel. A Luftwaffe squadron, even with technically superior aircraft, couldn't maintain air superiority when American factories produced 3 fighters for every German plane. A U-boat, even with experienced crews, couldn't win the Atlantic War when American shipyards built merchant vessels faster than submarines could sink them. Hoffmann understood all this, eventually. But understanding came slowly, purchased through the accumulation of observations that couldn't be rationalized away. The abundance of American trucks, the casual waste of steel, the industrial scale of supply operations, the simple fact that American guards ate the same food as German prisoners because manufacturing adequate food for everyone was easier than organizing hierarchical distribution. The 5 million tons of steel actual production, not hypothetical capacity, represented a level of industrial capability that German engineers like Hoffmann had never seriously considered possible. They had known America was wealthy, that it had substantial industrial capacity, but knowing abstractly that a nation produced 80 million tons of steel annually was different from confronting what 80 million tons meant when translated into actual military equipment distributed across multiple theaters of global war. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.